Good morning, everyone, or good evening for all those who are joining from India. We see some people who are joining early on from the West Coast as well, so very early morning. I'm based out of Melbourne, Australia, so for me it's midnight. Welcome to our session two. So this is will be a continuation to the last session, over where we discussed and talked about what is GitHub Action and how we link a GitHub Action to a Terraform cloud. So today I will be showing you the next steps to that, where we will be looking at some of the very fundamental Terraform operations. Let's say maybe we will look at creating an S3 bucket, applying some policy, and if the time permit, we can look into some of the advanced concepts of maybe how we loop through different variables, or we can also look into maybe creating a VPC, assigning, let's say, a DHCP option, or assigning your internet gateway. So let's see how it goes. So without wasting much of the time here, because we have already talked about this. So as I mentioned in my last session, I do not do any kind of trainings anymore. But if somebody is still interested to reach out to me, any kind of help or any kind of guidance, feel free to reach out to me. I don't run any paid trainings anymore, but I do mentorship, which is entirely free. And I can help the youngsters, or even some of the seasoned professional in the data or systems engineering space on what should be the next thing to look or work on. So in the last session, because we are syncing up after a quite long time, almost 2 months. Our last session was in November, and in December there was supposed to be two sessions, but due to COVID complications, I couldn't take those sessions. So we are resuming those sessions, and we will try to be regular now. So in the last section, we looked at what are GitHub Actions, how we set up the very basic tokens, how we connect GitHub to Terraform Cloud, what is an organization. But let me quickly give you a feel of that, what we touched upon, right? So in the old days, if I have to do a CI/CD, I will need to deploy some kind of a server. Usually, we used to use Jenkins. Still, a lot of organizations still use it. Let's say banks, where they're very critical about not exposing their data outside, and they want the full control of what they're doing. They are not very comfortable with, let's say, a SaaS kind of a model, right? Somebody hosting the service and they're not aware what's happening. So we still see those kind of operations, Jenkins servers and all, but there's an overhead in maintaining Jenkins servers, taking care of it, like taking care of high availability and installing all dependency, taking care of your jars and all. So all those things has been made easy by using GitHub Action. And the good thing about it is most of the part is free, unless you need some of the enterprise features, which we have discussed last time. So you will be able to do everything, whatever we have talked in the last session, or what I'm going to demo today as well, without needing any kind of license, both for GitHub Action and both for Terraform Cloud. And we discussed about the different version licensing options in our last session. So I would highly recommend that you go and watch those two videos from session one, which I have shared in our meetup channel as well. So in the last session, we talked about GitHub Action. So GitHub Action is a CI/CD platform that allows you to automate your build, test, and deployment pipelines. So the whole concept is you create a workflow. Workflow will have some jobs. Those jobs would be triggered by certain event. Event could be a push pull request, or you can do a manual run as well, event. And those jobs can have multiple actions, and those actions will be executed or run on a set of nodes, which we call them runners. So this is how it is, like the outer layer is your workflow. So the workflow, there will be an event which will be triggering your workflow, and there will be a job. There can be multiple jobs depending upon how complex your workflow is, but there will be only single job running on each of the runners. So think of runners as your virtual machines, VMs. You have the choice of choosing which VMs you want. So in most of our demos and all, we will be using Ubuntu. So when I say we will be using, means it is the GitHub Actions provisions that infrastructure for us. We don't need to worry about it. We just tell, okay, runs on Ubuntu latest one, do these steps. So for example, if we look at this workflow with the YAML file, I've given it some name, and I'm saying, I've given it some run name. And I'm saying on push, like whenever we do a push to this Git repository, you should run a job which has following steps, right? So a job can have multiple steps, or we call them actions. It can execute scripts. It can do installations. Let's say we are doing an npm install, right? So we can execute any bash scripts. But the important thing to keep in mind is there will be only one job per runner. And we also looked at Terraform in the last one. Like I can use my own open source self-managed command line, Terraform on any of my Linux machine and run it from there, or I can use a Terraform cloud as a SaaS offering. So let me just give you a feel of what we have done last time. So if you remember from our last session, so this is the GitHub account which we used. This is all in the deck, right? So you don't need to note about all this. So this is my main repository, Netzilon. Over there, if we go, there are a lot of other repositories for other things, but you don't need to worry about the repository which we are using in this session is your Terraform demo. And in this Terraform demo, in the last session, we talked about how we connected this Terraform to the how we connected this GitHub actions to the Terraform cloud, right? So here we created your actions. So actions were Terraform actions, right? So when I say Terraform actions, it will automatically create workflow files for me under this directory, right? So I modified them, but it will give you a good skeleton as a starting point, which we talked about in the last session. And in the settings one, important things we have talked about? If I go to the secrets, actions, and all those kind of things. So we have talked about Terraform API token, means when GitHub talks to your Terraform account, it should authenticate, right? So how we are authenticating? Using a token. And also which organization within that Terraform cloud. So let me go to my account. Again, this is again all free. So what I've done here in my Terraform account, you can see there are two organizations. One is Netzilon, which is my company, and another one is Helix Meetup. I've just given a random name, Helix, and I'm saying Meetup from this one. So there are two organizations which I've created. And inside that, if I click here, we have our workspaces. So all this we have talked about how we have set up this in our last session. So I will recommend Please go and watch it. So if I go to users, user settings, here we have set up this token. This token I'm using, I've just created this token today, about 5 hours back, just for this class. And I'm supplying that token here. I'm supplying that organization name here, so that when this GitHub action runs, it knows out of these two organizations, which organization I should connect, and within that organization, which workspace I will connect. We talk about that from our workflow, right? This also we discussed in our last session. So if I go to workflows here, if I go to any of my workflow, and if I look at this line here, this is setting up your Terraform workspace. And what is your Terraform workspace? TF underscore workspace is set to environment variable project name. What is your project name? Right? And your target environment means project name hyphen target environment. And what is your project name? Project name is variable is populated from here. Right? So if I execute this command, if I copy this, and if I go to my command line, right, you can see it is saying Terraform demo, means I'm sitting inside my GitHub repo, which I've checked out, and I'm just executing the command. So it is saying, if I do just this part, so this is all Linux stuff. So if I execute git reverse parts show top level, so it is giving me the entire path of that. So what base name does, it takes the last part after the forward slash, right? So that's what it is doing. So it's populating with the name Terraform-demo, and then it is saying hyphen env target environment, which is I have set up it as develop. So it will be Terraform, this name which has come from here, it will be Terraform-demo-develop. So if it goes here, it will look for that Terraform-demo hyphen that environment which I've set, which is whatever the target environment we talk about, right? So it will look for that. I was in the master branch, so that's why it's coming like that. So you can see here it is dev in the development branch, right? So let me show you here. I say git branch, I'm in the development branch. So let's do some operations here. Let's understand how this is working. So we don't need to look into this Terraform code here. Let's go to the repository demo here, and let's look at the project space, what happens here, and let's look at some of the S3 buckets which it creates. So let's say I'll just search by, because there's so many buckets, just for ease of visibility, I'm just searching by a string by which we will be creating that bucket, so that it's easy for us to track that bucket. So let's open the code editor. So I've done a checkout of my repository. So how Terraform is structured? So when I do Terraform init, Terraform space hyphen init, it automatically creates a structure for me. What structure it will create? It will create a Terraform directory. It will create an environment folder, and it will create a main file and variable file, provider file, and version file, right? It will automatically create. So when I say Terraform hyphen init, means if I'm doing it from the command line. So if here I'm using GitHub action, so the moment I created that GitHub action, as we discussed in the last time, it will automatically create dummy files for me. So now, important thing to look into how Terraform starts. First is in the version.tf file, we tell it what is the minimum required version of Terraform we should use. So what happened? There are a lot of developments and upgrades done to Terraform releases. So I may be using a module which might be outdated or deprecated, or there might be new features available in that module which might not be available in the older versions. So try to keep it to the latest version. So I am specifically saying here, Terraform should be greater than 1.2.5. Minimum version of Terraform should be that. And another important file is the provider file. So here, how Terraform knows I have to talk to AWS and what are the credentials I have to use, right? So it is populating these values, access key, secret key from GitHub, where we have defined all these things. If I go to settings, if I go to secrets and variables, you see here, we have defined AWS access key, secret key. These are variables, and I have populated them a few hours back with my AWS access key and the access token. So that's what it picks up. So nowhere in the code we are supplying any access key. It is all masked inside GitHub Actions, right? All these are all hashed, and you cannot see. If I go here and try to manage those environment variables or anything, I cannot change it, right? Let's say if I click here, if I change it, it will not show me the old one, right? It will just show me blank. So nobody can see it once they have been entered here. So let's look at it. So important thing first is provider. So Terraform, in the Terraform logic, what we are saying is, in the version file, we said, what is the minimum Terraform version we need? In the provider, we are saying, what is the AWS provider version? Means AWS will also be exposing different versions of its provider versions, right? So when I say AWS means, let's say Terraform, I can use Terraform for provisioning my environment in Azure, in AWS, in GCP. It has a provider for Databricks, right? So what version of that particular provider I'm using, so that's what it is specified here, right? So it may be for Azure, it will be different version and all version. Accordingly, it will support those actions on that particular cloud providers. And when I'm saying cloud in curly braces, as I've explained all this in detail last time, but I'm just doing a quick review. It means the state of all your operations which Terraform does, right? So let's say I say provision in an S3 bucket, or I say create some VPC. So it maintains a state of that, where it maintains. So if I'm giving cloud curly braces, it's maintained on the cloud, right? There's a backend database on that. It automatically maintains it. But if I'm not giving that, I can give my own local DB. I can give DynamoDB. I can store it locally, right? So please refer to my first videos on these. So now another important file is your variable file. So variable file is the file where you are defining all the variables you will be using. At the moment, nothing special. I'm saying some organization variable. I'm saying organization name, project name, region variable, environment variable. And you see here, I'm using this AWS default region, AWS key, secret key, all. These needs to be defined, right? So these all needs to be defined variables as string, which I have already defined. This is simple concept to any programming language. Whichever variable you use, you must define it. So I've defined it there. Now in the environments, right? So I'm saying dev.tfvars, right? So I'm populating here. So here I'm defining the variables, but I'm assigning values to those variables here. So if I'm creating a dev environment, so I can create a prod, test, dev, multiple environments. So in this case, I'm creating a dev environment. So what I'm doing is I'm populating those variables. I'm saying project name Helix, organization Helix, project name data, environment dev. I'm saying region US East 2. That's what I'm doing, right? And in the development, what I'm saying, the moment I push changes to this branch, which is your develop branch, I'm providing some environment variables. I'm saying it should trigger a job. What job it should trigger? It should look for an environment dev. It should perform all these steps, which is checking out this repo, setting up Terraform workspace, as I explained. It will look for workspace with the name Terraform-demo-dev, right? From here, environment populated that. Then it will set up Terraform. It will do an init on Terraform. It will validate Terraform, and it will plan and execute those Terraform, right? What it will execute? Whatever we have supplied, it gets loaded into the runner, into the working directory, and it will execute all those things and applies that, right? So let's do a quick demo. So let's create an S3 bucket here, right? Just for the sake of understanding. Just give me a second. Let me see. I think people are trying to join in. Give me a second. Okay, all good. So now let's take an example of an S3 bucket. So I've written some code in advance just to save on time. So the main file is the file where everything starts. So it is not necessary that it should contain some data. It can be blank as well, but there should be main file. Otherwise, Terraform will fail. It can be blank as well. So let's say I'm saying I'm using a resource. So this resource cannot be anything I want. If I go to Terraform documentation, it has defined resource for each specific thing. If I'm want to create an S3 bucket, I have to use AWS underscore S3 underscore bucket. This is any name I can assign to it, to that resource. And then I'm saying create a bucket with what naming convention? I'm saying pick up the variable org, which we have defined Helix, variable environment, which is dev, and create a bucket called demo1-zone. So there will be a bucket which will be created helix-dev-demo1-zone, right? And how these variables are populated? It will automatically be populated depending upon which environment it runs in. If it runs in dev, it will automatically say dev here. It runs in test, it will say test here. Accordingly, it will pick from the environment file. So at the moment, we have only one dev environment. So it's not an issue. But here, if you look here, so it is defined from this environment file in the workflow, right? So it will be, this is telling to pick what. So this name should match this name, right? So when I'm saying environment dev, this file should be matching that name. It cannot be, let's say I say develop.tfwars, it will not be able to pick that file because it should match exactly that name. So it is, that's why how it's knowing that file, I have to go and populate the variables. So now what I do, let's go back to main. Okay, not let's not make it public. I just copy some operations and I put some policies, making sure the bucket which I have created up there, it's not public. So how it is knowing? Now I'm using a resource AWS S3 bucket public access block, right? Again, it's a defined resource in Terraform. It knows what I'm talking about. I can give it any name. Obviously, the name which I use here, I cannot duplicate it. For each resource, this name should be unique, right? I can use S3 demo bucket here again because this resource is different. But let's say if I'm using this resource twice, I cannot have this same name. This name should be separate. So I'm saying for which bucket it should be. So I'm saying it should be for AWS underscore S3 underscore bucket. This one dot S3 demo one underscore bucket dot ID. It can be name. It can, you can pull in a lot of variables. It will be this one, but I'm saying ID. So now let's say save and let's do a git add. I say git commit -m created S3 demo bucket. Sorry. Oh, instead of commit, I've written commit. Okay. Then I say git push. Right. So I was on git branch. Let me show you. I'm on the dev branch. So see, the moment I did the push here, let's see what is happening there. If I go to actions, automatically it got triggered. So look at the comment. It automatically got triggered because in the workflow we have defined, if you go back to the workflow, in the workflow we have defined on push to this branch, execute all these things. So that's what it is doing, right? So it is executing. So here it is doing a plan, then it will do an apply. So if I go to this workspace, you will see nothing yet because it has not yet hit Terraform Cloud for apply operation. It is still validating, doing syntax checking, planning it out. And once everything is fine, it will connect to Terraform Cloud and say, okay, apply it now. So now you will see here, you will see it coming here in a minute or so, in few, not minute, even few seconds. Yeah, yeah, you see it's running. Yeah, see now. Initially, it does all those locally, then submitted it to Terraform Cloud. Terraform Cloud is taking that recipe, or I'm using the word recipe because I've worked a lot in Chef and all, but it's taking that workflow and applying it. Now applying it up here. See, it planned it and applied. Now everything is done. Now if I go to here, refresh it. See, there's a bucket created. Helix dev demo one region bucket access no, not public, right? So it created a bucket with that name. So now let's see, let's create one more bucket here. And before that, so let me show you one more thing. So it does not matter because Terraform is maintaining a state. As long as that state doesn't change, Terraform is intelligent enough to know that that resource exists, and it does not matter which file it exists in, right? And there's no order to it, right? It can be in any file. You can declare something above in the file and use it later, or use it above at the top of the file and declare it later. So it doesn't matter. So let me create a file, give it a name, let's say s3.df. What I'm trying to do here is, now I'm saying good practice is you keep the file name descriptive. Like looking at this file, I will know, let's say this file will talk about S3 buckets. or something related to S3. So what I will do, I will move this out, right? I'm just trying to show nothing changes, doesn't matter which file I put it in, right? Terraform is intelligent enough to know, okay, that this is something which I'm aware of. This was applied previously. These are the resources which I applied, and it doesn't care which file it came out of, right? So we are doing this. I will do a save here. Do a save here, right? This is updated, and I do a git add, and then I do a git commit, then I do again a git push. Right, so now you see all has been committed. I can see those modified and updated one gone here. And now let's go back to the Terraform one here. Go back to actions. See, again it kicked in, and you will see there will be no change. You will still see the bucket. You can put some file, nothing changes. It is not recreating it. It is aware of it. Doesn't matter which file it was part of. Right, so let it run. So in the meanwhile, let me demo you something else. So now let's take an example. I want to create one more bucket. Right, so let's say in the S3 one, I want to create, let's say, one more bucket. I've given it a name. This time S3 demo 2. And again, to that, I will apply some policy. I'm saying I'm blocking public access, right? So now we are creating one bucket is already there. I'm adding new bucket. This policy was applied to the topmost bucket. And this one will be applied to the second bucket. But here, let my previous action complete, and then we will submit this again. So this one will give me an error. Why it will throw me an error? As I explained to you, I'm using a resource here which is called AWS S3 bucket public access block, but I'm duplicating the same name. Access bucket public, access bucket public. So let me show you. I will run it. See, all this is separate. I'm trying to apply it on bucket 1. This I'm trying to apply on bucket 2, but I'm referring it by the same name. So it will throw me an error when I run it. Let it complete. So let me just show you. It doesn't change your bucket or anything. Right? Bucket is still there. So it doesn't matter which file it came from. So it will just take few more seconds to finish it up. And in the meanwhile, let me just commit the change. So what I will say, git add, and I'll say git commit created S3 bucket with error. I explicitly creating an error, and I will push, but let's wait for the previous push run to complete. Then I will push it. Okay, it is almost done. Right, so it is almost done. So it's finished. If I refresh it here, bucket is there. So now let's go back to actions. You can see we ran this one, these two. Now I will do a push here. So again, same thing. The moment I'm doing push, I'm not executing anything manually. The moment I check in code to my GitHub repo, my workflow kicks in. It automatically connects to Terraform and creates that resource. But in this case, now you will see it will throw me an error. in the logic itself. See how quickly it knew that there's an error in the logic. See, it's saying duplicate resource, right? Which I showed you. So I can give any name here, right? So let's say I give it S3 bucket to something, but I have to change that name. So I will save it. I will do a git add, git commit, creating S3 bucket. Not with errors now. I corrected it. And now I do a push. So now we will see that push will go through, right? So now it has started running. And after some time, we will see that bucket will be created. So in the meanwhile, it is running. So let me explain you something here, right? So now you're seeing I'm manually writing one block for S3 bucket. This is another block for another S3 bucket. And then within each one, I'm again copying this, right? So here there are 2 buckets, or let's say 10 buckets. I can manually copy that many times, but this is not a good approach. So I shouldn't be writing this code that many times, right? So what I can do is I can use loops, right? So instead of writing this so many times, what I can do is I can get rid of this one, right? And what I can do is I can do that for S3 buckets also, but let me show you in stages. So I will define something called a local variable like this, where I'm saying a list, which is a buckets. In that, I'm referring to these 2 buckets, right? AWS underscore S3 underscore bucket dot S3 demo1 and S3 demo2, right? Local. And then what I will do, I will get rid of this one with what? I will say, I would refer that in the for loop now. I will get rid of this and I will do something like this. So now I'm saying for each, or you can say I'm saying for index bucket in this linked list, it's just going through that, iterating, and it is assigning each dot value dot id. So as I said, value dot id. Why? Because if you looked into the last commit we did, we said bucket dot id, right? AWS underscore S3 underscore bucket dot that reference number dot id. So the same thing I'm doing, each dot value dot id, right? So now you see that completed. And if I go here and if I refresh it, now you will see 2 buckets are there, right? So now what I've done, instead of copying multiple times, what I've done, I've created a list. I'm looping it and I'm applying that. Now there's only one name here because there's only one block. So I save it and I again do this, right? I do a commit and I say git commit, created S3 buckets with loop, and I say git push, right? So now we will see here again, if I go back here to actions, you will see now again it kicked in with created S3 bucket with loop. So now it can, anyway, those 2 buckets are already there. So Terraform understands, doesn't matter what logic I am using, whether I'm giving 2 blocks separately or I'm looping it like that, it knows the state of what resources it created. So it will not destroy and recreate it. It will just know, okay, this bucket was already there. I don't need to recreate anything. We have just changed the code logic here. Great. So now in this one, Now, you may also ask why I have given this twice. There may be 20 buckets, 30 buckets. Yes, you are correct. I can also loop that in the same way, right? I can do for each for that as well, right? So these things can be done. So now let's look at something else within those buckets. Let it run through. Only 20 seconds something are left. Okay, we'll let it run. And in the meanwhile, I will show you another example within that one. So let's say at the moment, the bucket which we have created, let's say I will pick this one, Helix Demo 1. I go to properties. See, the versioning is disabled. Right? Versioning is disabled. And this, all these project keys, where they are coming from? They're coming from okay, sorry, where I've defined that here in the provider. I'm saying default tags. Wherever I don't give any tags, it will pick from this file. So the same thing you see here. I can say contact DevOps team or my email ID. So now you see the versioning is not enabled for demo 1 bucket. So what we can do is let's upload something inside this bucket. Right, so let's upload something, add file, just for the sake of this one, I will just do GitHub Action PDF. Okay, it's not a very big file. From session 1, upload. I have uploaded that file. Let's go to that bucket, properties, versioning is disabled. Okay, so this action ran completely, successfully. So now what we'll do is, I will go to my S3 bucket, and what I will do is, I will enable versioning for one of the buckets. So I can either use the loop logic, but let's say I'm doing only for first bucket. So I'm saying this name. Okay. So what I'm doing, I'm saying resource AWS S3 bucket versioning. I'm giving some name, arbitrary name. Obviously, it should be meaningful later on in a bigger project. That looking at that, you can know what that rule is. And I'm saying for this bucket, which I'm referring by S3 demo 1 bucket.id, I'm saying enable versioning on that, right? So I will just go and save this file, and I will go here. I will do a commit here. Enabled S3 version. And then I'm saying push. Refresh it. Now you will see that commit has been pushed. I did it executed. So how it is running for, I think I see a few people joining in late, but I will highly recommend you go and watch our first session recording, which I have posted in the meetup. So if I'm going to work group, within Terraform directory under .github under workflows, develop.yaml. So this is the logic which is making it. Okay. The moment I commit any change, push any change to the development branch. So I'm making pushes all to the development branch. If you look at my branch, I'm on development branch. I'm pushing whatever changes. So it's this workflow is kicking in on push. It is picking up all the environment variables, where to connect with what credentials, and it is running that job, which has certain steps, right? So it is doing Terraform, validate, plan, init, execute all those steps, right? And saying auto apply, right? It is auto apply. So let it run through. Almost there. Versioning is still disabled because it is still running. If I go to Terraform, you can see it is still running. Planning, it is not in the apply phase yet. You can see it's still running. In the planning phase, not in the apply phase. So once it transitions to the apply, see now it's saying applying. So as there are not many changes, what we are just creating a bucket and applying there. So it will be pretty quick. See, versioning got enabled. And if I go here, the objects and all will be there, whatever I loaded, right? So this is how we are creating that one. So now let me show you here one more thing. As I said, like you can obviously go and refer to my first session one. So if I go to environments, I'm using dev environment, right? Now, see, the moment I was making a push, it was automatically executing, but I can also add reviewers, right? I'm saying required reviewers. I can give someone's email ID. Let's say if I search for my name, it will come, but I can give other people's as well, right? But let's say I don't give any reviewers. I say require reviewers. So I'm adding myself as a reviewer on this, on the GitHub action, right? Say protection rule, right? So now let's see what happens now. Let's make some changes. Now I say from, let's say, let's do something else now. Maybe make a change. What I do is I remove this S3 bucket now. Or what we'll do is, let's do disabled here. Right? I'm doing disabled. While save, I'm disabling versioning. Right? And I'm saying disable. Right? Now I do push. Right? Now let's go to my GitHub Actions. See, initially it was executing. Now if I go here, it is waiting for my approval. See, I have to review the deployment, right? So initially it was automatically executing. Now I have to review it. So in the coming sessions, I will show you, we are just working on dev branch, but now we will create multiple environments. We'll create maybe a test and a prod, and then we will see how when we merge a code from, let's say, a development branch or a feature branch to the main branch, how it does that automatic code checking, how it asks you for approval. Once you approve it, it merges and automatically makes changes to the environment, right? So we'll look at in the upcoming sessions, but this one, simple one, let's say if I take it, now I can review. I've said, okay, go ahead. Now it will start executing. So it will take few seconds, and then again, you will see that approver has applied. So now let me delete this file, because what I wanted to show you is, I want to show you another action which we can do from this one is, let's say if I go to actions, at the moment, I cannot execute this development manually, right? I cannot deploy this develop manually. Okay, let's see what has happened, why it has failed. I think I might have done some spelling mistakes. Oh, okay, can't be updated from enable to disabled. Okay. Okay, I think the objects have already been changed. Okay, cool. I will fix that back there. So now what I was saying was, I cannot execute this development manually. I can only go by push method and execute. But in the case of a destroy, I put up a logic where what I'm saying is, you select a branch, you are saying which main branch, which environment to deploy, and it is asking you, are you sure, right? So let me show you, it will fail, but let me show you why it will fail. Let me go back to the workflow. Let's go back to the workflow, destroy workflow. So here, this is the logic I have written. So I'm saying do a workflow dispatcher, and I'm saying environment to destroy, required is true, default is develop environment, and it is giving you warning, you message you see, and it requires true unless somebody says tick there true boolean, right? True, then only that action will kick in, which is destroying your environment, right? So if I go here and let me go to destroy, and if I run this destroy using the dev branch, I'm saying use the code in the dev branch to destroy which environment? Dev environment. It's asking, are you sure? I'm saying yes, and I'm saying run workflow. So now, although Terraform has built everything, like it has built S3 bucket, gave versioning, gave all those, made it non-public and all. But what I have done here is I have copied a file in that bucket. So obviously when a bucket has data in it, as a safety check, it will not be able to delete that. I can force it. There's a force option as well. But obviously in production, we will never use a force option, just to ensure if any bucket has a data, it doesn't drop that. So in my case, it will fail. This action will fail, destroy. So if I go here, anyway, destroy is asking me for approval, because I have said destroy should always ask for approval in the workflow I showed. Now it will fail when it is trying to do an apply. So I will show you here on the Terraform. When it reaches there, it will say now an empty bucket. So let me go back here. And there were two buckets which we created with the name Helix, which was our project. This one, demo one, has a file, means it is non-empty. This one is empty, right? So let's look at it now. See, it failed even before reaching the applied stage. Okay, so let's first fix our old one. Even before running destroy, let's enabled Let me just fix that. First one, and we do a push here. So we set it enabled S3 version, and I say push. Let's go back to my GitHub Actions. That enable one ran. It is asking me for review and approval. I say okay. Now we have reverted that. It will be pretty quick. Because as I said, it maintains a state. So it's quickly doing a checksum and ensuring what has changed from the applied state. It knows, okay, it just does, okay, quick, there's nothing much changed. And let's go here. Like if I click here in the plan, you can see what it is planning. Right? See here. So it has planned, see, refreshing state. See, if you look here, refreshing state, right? So it knows nothing has changed. Otherwise, it would have said creation, deletion. It will say actions like that. So let's go here. Now it is again asking me apply time, right? So it's asking for approval twice. One is when it is running, building up your planning phase and all. Now it is submitting to your Terraform cloud. If you see, you will see here, it will come to this Terraform cloud now. Yeah, so as I talked about this in the last session, so GitHub and Terraform, all I'm using free account, right? So in the GitHub one, as long as your repos are public, you can do everything whatever I'm showing. The only restriction is in the non-enterprise one, there's a limit on how much compute I can use. So example, I'm using GitHub Action. So GitHub is provisioning the underlying infra for me, creating virtual machines, the runner where the code is compiling, it's running action and connecting to GitHub and connecting to Terraform. It's costing them money. So there's a limit to that, right? So I don't remember from the top of my head. I think it's 300 hours something uh, per month or something, which is still very good enough for a free account. Okay, so this completed now. So now let's go here and I say destroy action. Quickly, I will show you destroy. It will not let me destroy because it will say bucket non-empty. Let's click here. I will remove the old one, which failed. Yeah, so destroy. It's saying, okay. I'm saying review deployment. I say proof and deploy. And this gets very interesting and complicated as well as we go along. So here, as I mentioned, there's only one environment, but I can create prod dev test, right? And you can see how your branching strategy is, and you can define, okay, the code approval should be automatic. When you go from one branch to another branch, what should happen, right? And which branch it should commit from. For example, you see there are two protection rules which I have put up here, right? One is obviously reviewer one, but I'm saying which branch is allowed to push to this, right? So I'm saying dev branch. So in the prod one, in the prod environment, there will be a rule in place similar to that where we will be saying a deployment to the prod environment can happen only from the master branch, right? So that any code which is in the feature branch or development branch doesn't go to prod. And we will have a branching strategy in place where we will say, you cannot directly push to master. You have to always raise a pull request from your feature or development branch, and then somebody manually approves it. Then only it goes to master branch. And your prod is always from master branch. So I will show you all that in the next session sometime. So let's see what has happened to our actions. Okay, let's say destroy, and I'm saying review. Let's say approve. So let's click this one. So it's checking out code, Terraform init, Terraform validate, apply. See, it's doing all those things, validate, Terraform apply. Waiting for plan to start. So obviously Terraform doesn't know that there's an object inside the bucket. When it will go and try to remove that bucket, obviously it comes into, the checks comes into place and say that bucket is not empty. See now here, see, it went there, refreshing state, and then it went to destroy one. Terraform will perform destroy. See, it's saying it's went on that action. And if I go up here, all these things, look here, error. It's non-empty. You saw the error there, right? The bucket is non-empty, right? So that's what it gave you a message there, right? So if I go here, refresh, so it removed the other bucket, but not this bucket. So what I have to do, I have to get rid of this now, file if I want to do it, or I have to manually delete it. So I delete this now, and I say permanently delete. Delete object, close, okay, cool. And what I will do is, instead of submitting all those flow again, I can say from here itself, or I can pick this one from here, and I can say rerun all jobs. Asking me for a view, apply, and now the other bucket will also go. So this was the whole intent of this session. So I will upload the recording. And again, there are so many ways here. So at the moment I showed you that we can only deploy using automated push. I cannot do a manual run from here, but I will show you next time also how we create a file similar to a destroy file with a drop down where I can say deploy to which environment from which branch, right? You can drop down and you can deploy from there. And also you can put in checks in place. So I think that's all. Any questions anyone has, let me know. I can unmute them. Okay, cool. Is there no questions? Okay, let me just prove this one as well. Cool. If there are no questions, then we will close this session and I will share the details about the recording and all on our meetup group. And if you are looking for anything specific in this, because again, this is a very vast topic, the intent of these sessions are not training, but just to get you introduced to what's going on in the market and what are the capabilities we have. So gone are the days where we used to set up heavy Jenkins servers and all. Yes, people still do in banks and all, where they want a tight control on their CI/CD pipeline and how the builds are done. but most organizations prefer this way because you don't have anything to maintain. Cool. All good then. I will stop the recording